In this example, we just want to match the equation with each graph. Now, we don't want to use a calculator or anything. We just want to match each equation with its graph. And so what I would do is probably, we know that the a value controls where the graph crosses the y-axis, right? So I might first of all try to look at the a values because we got several different a values here, right? Here's one, that it's going to have an a of 4. These are going to have an a of 2. All of those curves that pass through that y-intercept. And then here we have, here the y-intercept is -2. So a has to be -2 here. Here a has to be 2, and here a has to be 4. I'd probably start with that because there's only one that has a value of 4, right? And so this one, letter C, has to be graph C. We have 3 that pass through 2 and 2 that pass through -2. Let's look at the ones that have an a value, an initial quantity of 2. So I'm just going to highlight those. Those all have a +2 a value. So let's try to sort out which is which. All right, this one is growth, right? Because B is greater than 1, right? B is greater than 1, so it has to be growth. This one also has to be growth, right? Because it's the B value is 1.1, so it's growing by 10% each time. This one has to be decay. All right, so of the 3 that pass through the point 0, 2, right? They have a y-intercept of 2. The only one that's decay is A, so I'm going to say that this is A. And then the other 2 are both growth, so which one's going to grow faster? The 1.5, 2 times 1.5 to the x with a b value of 1.5, right? That's going to grow faster than 2 times 1.1. This is growing at 10% each time period, and this one's growing by 50% each time period. So this equation A is going to grow faster, right? So of the 2 that are passing through, we have B and D that are passing through the y-intercept of 2. The one that's growing faster is B. So this one has to be B, and so this one has to be D. All right. Then we have these negative ones. We have the negative a values, all right? We have those 2. We have to sort out which is which. All right? Now, our B value is negative, or sorry, a B value is 0.7, right? So this is decay, but it's decay in the negative direction. So it's sort of negative decay. Now, these values are always going to be negative, right? Well, and you can see from the graph too that these values are always negative because 0.7 to any power, it doesn't matter what it is, whether it's a positive or negative x, 0.7 to any power is always positive, and we're taking it times a -2. And you can see that as x gets bigger and bigger, 0.7 to the x is going to get smaller and smaller. You can try that on your own. You can look at 0.7 squared, 0.7 to the third, 0.7 to the 10th, and you'll see that 0.7 always gets smaller and smaller. So as x gets bigger and bigger, it's multiplied by smaller and smaller things. So you can see this is sort of it's negative decay. It's decaying as x increases, as x increases. And it's negative, but it's becoming smaller and smaller. So this one has to be F. And then the other one is the process of elimination. This one has to be E. Now this one is growth, right? It's growth, but it's growth in the negative direction. So it's negative growth. So you can see that as x increases, the value of y it becomes more and more negative, right? So the the magnitude is increasing, but it's increasing in the negative direction. So we have negative growth. All right. Well, I will meet you in the next video.